Welcome. I'm going to give a basic primer on greenhouse gases in the real world, not computer models, for your consideration. My name is Louis Laughlin. Visit my website at www.llaughlin.com. Let's get to it. Okay, this is from the NASA Earth Observatory. Here is their web address if you want to go there visiting it yourself. As of June 2023, this is the distribution of water vapor across the world. You can see the scale here. What this means, and it's in centimeters, that if you look down on a particular spot and you looked at it as a column coming from the surface to space and compressed it, you would have water that's, for example, in the dark blue, could be 6 centimeters or more. In the areas that are white is little to no water vapor. And just looking at this, Antarctica has very little, if any, water vapor because it's cold, because it's cold. Western coast of South America is arid. A lot of South Africa is arid. North of the Himalayas and large sections of Asia are also arid. In fact, Saudi Arabia, as much desert as it has more moisture than say the areas of the Himalayas, but that doesn't mean necessarily it's going to rain. That's a different subject. So note, your water vapor distribution is going to be where it's the warmest. It's the warmest because A, it receives the most sunlight, B, the water vapor retains the heat. Water vapor is the greenhouse gas on Earth. All right, according to the University of Arizona, on average about 0.4% of the atmosphere is water vapor, but in practical terms, the vast majority of it is going to be, like you saw back here, it's going to be heavily concentrated at the equator, and depending on the time of the year, whether it's summer, winter, fall, or whatever, that distribution will move north and south with the seasons. Let's eliminate a myth right now. Greenhouse gases do not trap heat. They re-radiate it in all directions. High cirrus clouds allow most of your visible and light to pass through. It reaches the surface, and some of it is reflected, some of it is absorbed and becomes short wavelength infrared. At the same time, according to NASA, these high cirrus clouds will reflect shortwave radiation back to Earth. Most of this, though, seems to be in the upper atmosphere. It doesn't mean it gets down to the surface. This is low energy infrared. Normal cloud cover, which is going to be generated anywhere that you have a large, heavy concentration of water vapor, your cloud cover, of course, is going to reflect most of the visible light, let some of it through. That's why on a cloudy day it feels cooler. At the same time, the water vapor in the area will absorb the infrared and re-radiate it. This is pretty simplified. Actually, it's radiated in all directions. Left, right, this way, straight up, straight down, this way. It's radiated in all directions. This is sort of simplified. And so the water vapor, through radiation and re-radiation, can store heat for a while, but it will eventually radiate it all out anyway. Why are deserts cold at night? Very simply, lack of humidity. Because there is no real other greenhouse gas there. Without humidity, the infrared radiation from the cooling sand, rocks, or whatever is radiated directly into space, and thus it gets cold. Finally, let's look at your concentration of gases in the atmosphere. Remember from our first slide that up to 4% of the atmosphere in the tropics and large areas along the equator, water vapor could be as high as 4%. According to NOAA.gov in July 28, 23, we have 350 parts per million, or 0.035% CO2. Well, that divided into 4%, water vapor to CO2 is 114 to 1. For all practical reasons, carbon dioxide plays no substantial role in warming anything. There's just not enough of it. Even more amazing is how little methane is really. They make a lot of hysterical noise about methane. Okay, methane, by the way, CO2 is 0.035%. Methane is so rare, it's ridiculous. You would have to have really advanced instrumentation to even detect something this small. Thus, methane is 0.3 more zeros, 17% of the atmosphere by volume. Nitrous oxide is another thing that they're really hysterical. That's 0.31 parts per million. That's 0.1234031%. Nitrogen oxide's another one they're really upset about. 0.1234502%. So, water vapor is your greenhouse gas, and it is impossible to do any kind of computer modeling to predict future events because water vapor is so variable. Thanks for listening. Have a great day.